Okay, so now we will see economic load dispatch. This is very small topic. In this, we will be discussing about load curve, how to find out average load, what are the units of number of units. Then we will be seeing shortcut for various factors. Then we will look into optimal load sharing in losses and in lossless and with loss wala condition. Then we will look into some of the cases which frequently comes in exam. Then we will look into some important points and we will quickly skim through some important questions. So first thing first, load curve. So load curve is a curve between power demand in megawatt versus time. Average load is nothing but area of this curve upon T. That is the time period. Then number of units is always given in kilowatt hour. Number of units is equals to average load into time. Only thing we should be taking care is it is given in kilowatt hour. Fine. Then the shortcut will start in clockwise direction for various factors. It starts from average load MD1 plus MD2 and so on. MD meaning maximum demand 1 plus maximum demand 2 and so on. Then comes connected load and then comes the rated capacity. In between will come the maximum demand. So ratio of average upon maximum demand is load factor. Ratio of MD1, MD2, MD3 and so on upon maximum demand is diversity factor. Ratio of maximum demand upon connected load is equals to demand factor, and ratio of maximum demand upon rated capacity is power plant utilization factor. Ratio of average load upon rated capacity is plant capacity factor, and subtraction of rated capacity minus maximum demand is nothing but reserve capacity. Fine. So with this particular shortcut we will be able to almost able to give answers to all factor related questions. Okay, so you can pause this here and one time have a look at this shortcut. This is a very important shortcut here. Okay, so now we'll start optimal load sharing in economic in losses and without losses condition. So with losses and without losses there will be slight differences formula. Okay, so important term to remember here is incremental cost, IC. Incremental cost is nothing but df upon dp. Okay, so in lossless condition for optimal load sharing, incremental cost of all generating stations must be equal. So IC1 must be equals to IC2 equals to and so on. With losses there is one more factor called as load factor which gets added, and load factor is nothing but 1 upon 1 minus P loss del P loss upon del Pg. Fine. Since it is a loss factor, since it is with losses, this loss factor gets added, and the denominator is called as penalty factor PF. Okay, so the formula becomes IC1 minus IC1 LF1 is equals to IC2 LF2 is equals to IC3 LF3 and so on, wherein LF is equals to 1 upon 1 minus del P loss upon del Pg. Fine. So some important cases here are, suppose there is a IC curve. Okay, let's say one of the IC curve is like this for one PG in PG1 and for 2 it is like this. Now here we can clearly see that IC of 1, IC1 max, okay, I'm so sorry, let's say it is like this. So IC1 of max is lesser than IC2 min. Okay, IC2 max is lesser than IC2 is lesser than IC2 min. Okay, this is the condition. In this case we will try allocating maximum load to IC1 max for optimal that's in optimal load sharing. Fine. Then there are questions where you will get P1 equals to 0 kind of thing. In that case you will find you will allocate 50% load to 1, 50% load to second, and then you will be calculating IC1, IC2. Then question can be in two form. It can ask IC1 minimum, I mean IC minimum, IC max, or it can ask total IC. If it asks IC minimum, in that case you will find IC1, you will find min of IC1, IC2. If they find maximum, you will find max of IC1, IC2. If they ask total IC, then you will just add IC1 and IC2. Fine. Now one of the point to consider in losses so one thing here, without losses, basically in lossless condition, maximum power will be shared with to minimum IC basically. With losses the condition is reversed. Maximum load is shared to the station with more IC. Fine. The reason for that lies in the formula itself. Okay, IC1 into LF1 equals to IC2 into LF2. Let's assume penalty factor of 1 is less than penalty factor of 2. So LF of 1 will be less than LF of 2. In turn, IC1 will be greater than IC2. But in lossless, with loss condition, our major priority, with losses condition, major priority lies with penalty factor. We'll never want to have more penalty. So whenever we share load, we'll try to minimize the penalty and we'll share the load in such a way, despite incremental cost is increasing, we will try sharing more load to the ones having low penalty factor. So in practical scenario, what happens is, generator having less penalty factor will have more load sharing. That means generator with more IC will have more load sharing. This is in case of with loss, practical scenario. In lossless condition, you will definitely try to minimize IC. Okay, so the generator with IC1 less will be having more load. Also, one more point to consider is, suppose there is a generating station far from this point, from this bus, and one generating station is very near. So in losses condition, since path is increased, resistance would increase and penalty would increase. So we would prefer to share load to nearby bus than to share to the further bus. Now we will look into some of the problems. So yeah, we will see problems. The first problem is, there is given some limit. So whenever you solve, here we got P1 as 83 and P2 would be something. So firstly, whenever limit questions are given, we would check the limit. We will see P1 ka limit. It is maximum load is 80 only. We are getting 83, which is not possible. So we will share whatever maximum is possible. That is 80 will allocate to P1, the rest will be allocating to P2. Then next question comes, wherein 3 different ICs are given. So we have tried plotting it. Okay, we have tried plotting it. We saw that iska maximum is lesser than both's minimum, right? Other two minimum. That's why whatever maximum possible load could be given to P3, we gave it in, and then optimal sharing we found out in the rest of the two. Okay, for this two we found out the optimal load shared. Then this is also a very beautiful question. In this we've got P1 as 0. So we have seen that in special case, when we get P1 0, and here they asked to find out minimum IC possible. So we got P1 0. In that case, we have equally distributed the load to both the things, and then what we did is, we found out IC minimum. Okay, so for one we got 32, for other we got 20 after allocating equal loads. So since they have IC minimum, answer would be 20. Okay, now with losses condition, again as I told, minimum losses generating scheduled for supplying 120 megawatt as economic. Most economic would be the closest one. The closest here is the 25 kilometer line. So most load will be shared here. Just see the options with the most load there. Okay, with most load come the maximum losses. So losses will be supplied by the same generator, okay, generating station. So this concepts we have already gone through. Then this question comes, this is a norm, so this is also an important question wherein we are dealing with the Ploss, but here Ploss is given in per unit. Now the major concept lies here is, when it is given in per unit, MVA inverse you will do, okay, MVA inverse you will do. What does that mean technically? So usually when per unit is given, we'll multiply it with MVA to get the actual value. But when losses are given, what we will do is per unit into MVA ka inverse. Okay, that will give us P actual. Okay, while after doing that only we'll substitute. So this is one of the very important concept to be taken care of. Okay, so with this we have also completed a load dispatch. Please note this point, very important this is. Okay, fine, so we can move ahead. We'll see next load flow analysis. Thank you.